that your teacher gave you to review?
Yeah, it was.
Okay. So where do you want to begin on this page?
Could we?
Do you want to do number one?
I think there's an equation for it.
Well, that's why I asked. Do you know what it is? In other words, they don't let you use a cheat sheet or anything, do they, on the test?
No.
So you got to know these equations. So what's the equation for the sum of the interior angles of a polygon?
180 n minus 2 over n.
Well, that's the sum of each angle. But if you want just the sum of the interior angles,
okay, so 180 n minus 2.
Have three sides, so triangle's sum would be 180. Rectangle's sum would be 360. So if you're ever in doubt of a formula, just try it on some common figures and make sure it works. So what's my equation going to be? In other words, we have to solve for n. So in order to solve for n, I need to have an equation with n in it.
So n minus 2 times 180 equals 3780.
And then just solve for n.
Okay.
And you distribute the 180. So you get 180n minus 360 equals 3780. And then 180n equals 4,140. And n equals whatever that is divided by 180.
Okay.
Okay. Now, the formula you mentioned, n minus 2 times 180 divided by n, that's going to give you what each interior angle is of a regular polygon.
Okay.
But it's only regular. In other words, if I have an 8-sided octagon, this is only true if every angle is the same. I could draw an 8-sided figure where every angle was not the same. In other words, I could draw it so that it's not regular. And then that makes a difference. You can't use this formula if it's not regular. But if it's regular, yeah, that's the sum of the angles, and there's this many sides, and so each angle is going to be that.
Okay. That makes sense.
So the measure of each interior angle of a decagon.
Decagon is 10 sides.
Okay.
So
that's what?
It'd be 10 minus 2 times 180. And then divided by 10.
Correct. Whatever that number is. We don't need to spend our time doing arithmetic here. Find the measure of each exterior angle of a nonagon. How many sides is a nonagon?
Is that 9 or 7?
It's 9.
Okay.
And what's the sum of the exterior angles of any polygon?
360 degrees.
So how do I get each one on a regular nonagon?
360 divided by 9?
Equals 40 degrees, each one of them.
Awesome.
Now, number 4 looks a little new. I haven't seen any. It's the first time I've seen a problem like this. Find x and y. Without me spending the time to redraw this thing.
All right.
What's x gonna? Well, yeah. How am I gonna solve for x?
Well, x is 25 I mean, x is,
Okay, you're right. Keep going.
yeah. So 7 plus 8 plus 2 plus x equals 25.
That's all you need. In other words, you could have said x was 25 minus 7 minus 8 minus 2.
Okay.
That is what x is. What's y? Ooh, y is, oh yeah, no, we just have to study the figure a little bit. What's y?
Y is, y plus 5 equals 11.
Okay, so y is
Y is 6.
11 minus 5, yeah. Okay. Boy, that was a complicated figure to draw just for those two questions.
Yeah, I've never actually seen one like that before.
They didn't need
For,
the dimension of 4. That was completely irrelevant. We didn't use it. Interesting. Okay. What's the midpoint of a line whose endpoints are that? What's the x-coordinate?
Is it in the midpoint of a line segment?
Always
Would that be...
remember the midpoint is the midpoint of the x's and the midpoint of the y's. So what's the midpoint? Yeah. What's the midpoint if I have an x of 8 and an x of 0?
8 and 0 would be -8.
The way you find the midpoint is to add the two together and divide by 2.
Okay, so it'd be 4.
Right, but let's just make sure you see why. There's 0 on the x-axis, there's 8 on the x-axis. Midpoint is halfway between them.
Okay.
On the y-axis, what's the midpoint between +3 and -3?
0.
Correct, because you can see that, but also add them together, divide by 2. So our midpoint is 4, 0. So how do we determine if two lines are parallel?
Parallel is the same slope.
Okay.
Right?
They're talking about AB, BC, AC, and BD. So we're going to need to figure out the slopes of all of these lines. So what's the slope of AB?
AB would be 2. Is it just 2?
2 over
2.
What's 2 over 2 equal?
1.
BC.
BC is 3, -6.
Now always subtract the y's first. Your rise is the difference in the y's.
Okay, so -6, 3.
-6 is the numerator. What's the denominator? 3. So that slope is -2.
Okay.
CD. What? Hold on. They don't ask about CD. They ask about AC. What's the slope of AC?
-4 plus -4 5.
It's a ratio. It's rise over run. So -4 is the numerator, but what's the denominator? You said it. It's
5.
Not times 5. Okay. It's not -4, 5. It's not -4, 5. It's -4 divided by 5.
Okay.
In other words, the slope is -4/5. Okay. And finally, they ask about BD. So what's the slope of BD?
-4 divided by...
Actually, -5 minus
Oh,
1 minus 4 is -5.
okay,
Divided
-5
by
minus
1
4.
minus 3 is -4. So the slope of BD is positive 5/4.
Okay.
Now, are there any parallel lines? I've got 4 different slopes. I've got a slope of 1, a slope of -2, a slope of -4/5, and a slope of 5/4.
No. No
No
parallels.
parallel lines because the slopes would have to be the same. Are there any perpendicular lines?
Perpendicular would be AC and BD.
Correct. In other words, to get perpendicular, you have to not only flip and also change the sign. So that's
Okay.
what you do to go from there to there is you flip and change the sign. So those two are perpendicular. Those two are neither parallel nor perpendicular, so they're neither. So that one's neither, that one's perpendicular. What do I know? What is this line here called? Number 7.
It's kind of like the midpoint.
Mid-segment.
Okay.
Okay. It's the
Yeah.
mid-segment because it bisects that side, and it also bisects that side. And we're looking at a parallelogram. We're looking at a trapezoid. Has exactly one pair of opposite parallel sides. So what do I know is true about the mid-segment of a trapezoid?
That it is half as big as the top one.
No, it's half of the bottom plus the top. It's
Okay.
average. Okay, if you average 40 and 34, you get the mid-segment. So it's halfway between there. So what's halfway between 40 and 34? You can do it 2 different ways. You can add them together and divide by 2, or you can just figure out the number and see if it's halfway in between. What number is halfway in between 40 and 37?
37.
Correct. So x plus 3 equals 37. So x is equal to 34, which is a little confusing here because this bottom side is equal to 34. But remember, x is just a variable. This mid-segment is 37. When you reflect a function, that's a function. It's only 3 points, but it's still a function. When you reflect it across the line y equal x, you're creating its inverse. What is true about an inverse relative to the original function?
It's like a mirrored image.
Yes, its x and y coordinates switch. So the mirrored image of A is 5, 6. The mirror image of B is 8, 3. And the mirror image of C is 1, -2. Remember that when you're dealing with inverses, the domains switch and the ranges switch. And the domain is the x, the range is the y, so your x's and y's switch. And you could verify that. Let's say you forgot that that was true. Well, let's just take 1 point. Let's take 3, 8. Okay? And I take a point that's, the 2 numbers are relatively far apart, as opposed to 6, 5. Those are very close together. Okay? Now, it says reflect across the line y equal x, which is what all inverse functions do. So I know that that point is going to be right about there. Well,
Okay.
it's clear that that point, if I just switch my x's and y's, it makes a lot of sense that that would be 8, 3.
Yeah.
And if I put another point on there, minus 2, 1, and switch that, well, that becomes 1, minus 2. In other words, make that perpendicular and equidistant. That's what you do when you reflect a point across the line y equal x. And so this figures to be 1, minus 2, and it looks to be that also. So a lot of times you can take what you're not certain of is the formula and graph a couple of points and see if it makes sense. In other words, is it really true that all we have to do is switch the x and y coordinates? Well, you can kind of prove it to yourself that it is true by doing it with just a couple of them. How are we going to get A? Start with A.
Okay. Well, we can find the sum of the interior of each interior angle for the pentagon.
Okay, figure that out. What is each interior angle of the pentagon?
3 times 180
Divided by?
5.
Okay.
And whatever that is, equals A plus the interior angle has to equal 180 degrees.
Right. In other words, whatever that angle is, it's supplementary with A.
Yeah.
Okay. Let's do the same thing to figure out F.
It's kind of the same process with the...
Correct. That's an octagon.
Yeah.
So you can figure out F.
Yeah.
G is a little different. How would I figure out G? I'm going to draw just part of this. Do I know that angle?
Yeah.
Can I figure out this angle?
Yes.
What do the three of them have to equal?
180.
360.
Okay.
You see why? Whenever you're going around a point, it's 360. It's only 180 if you had a bunch of angles that were made up. In other words, all of these angles have to add to 180. But if I put in a couple of angles down there, 1 through 8 have to add to 360. Okay, you see why?
Yeah.
Okay. And that's going to allow you to calculate G.
Okay. That makes sense.
How are we going to calculate H?
Since you know the angles of the rest of them, you can find out how many degrees the entire.
What is the entire degrees equal to? It's a quadrilateral.
360.
Okay. So we now know A, we know F, we know G. H is 360 minus the sum of those three angles.
Yeah.
Okay. If this side is parallel to that side, and this side is parallel to that side, well, at a minimum, it makes this a parallelogram, right?
Yeah.
Okay. So why is ENS, this angle right here,
All right.
similar to which other angle?
ENS.
That's the one that they're asking about, but they're saying that is congruent to which other angle? What is that congruent to?
That is congruent to the other side.
Can you name it? I don't see the letters, but I think it's
It's
that's N.
S. Yeah.
That's N and that's A.
So, yeah. So EN, that angle right there is, or SNE is equal to NSA.
Correct. Because they're alternate interior angles of two parallel lines. In other words, the theorem is the alternate interior angles of parallel lines. Notice we do not know that's a rectangle. Nowhere did they tell us that's a 90-degree angle. $11. 12 is pretty easy, right? What equation comes from 12?
5x minus 21 plus 2x minus 9 equals 180.
Okay, you can solve for x. On number 11, EMA, this angle right there.
Yeah.
Let's see. First of all, they're telling us that MN is congruent to MA and that ME is congruent to MR.
Oh, yeah.
Interesting. They don't give us the third side congruency. In other words, they don't tell us that EA is congruent to NR. Why not?
Equal because of side angle side?
Correct. It would be congruent. But it's a funny question because what is EMA congruent to?
EMA is congruent to RMN.
Yeah, why?
Because of side angle side.
Not really. It's because they're the same angle. In other words, it's because of the reflexive property. Now, what you're saying is true. In other words, once you know that that angle is equal to itself, now because we have side, angle, side, we know those two triangles are congruent, but we don't have to use the fact that they're congruent to prove that angle is equal to itself. That's the first thing. The congruency comes afterwards. So proving that that angle is equal to that angle is the reflexive property. That's why I said it's a little bit of a funny problem. I would know this answer without this information. You could not give me this information and I would still say AMA is congruent to AMN or AME or however other way you want to define that angle, but it's congruent because it's the same angle, the reflexive property.
Okay.
And then, given the fact that that's congruent to itself and that these two are equal, then you could say that the one triangle is congruent to the other. But it doesn't really ask for that. The only thing it asks for, you can answer completely without this information. So I think this is a bit of a typo or logic gone wrong or something.
Okay.
Mark, you good to go until tomorrow?
Yeah, looks all good.
Okay, and we're just going to do the other sheet tomorrow, or do you have more stuff to send?
I think I'll send you something else tomorrow.
Okay, cool. I'm stacked again tomorrow, back to back all afternoon. So if you could send it to me before the session, we'll save a few minutes.
All right, cool.
And I'll talk to you at 4:30 tomorrow.
All right, thank you.
You're welcome, Mark. Have a good one.
You too.